you by thesis123.com. I learn and teach online.
Here's the next question, number 45. A full bridge converter supplying an RLE load is shown in the figure. The firing angle of the bridge converter is 120 degrees. The supply voltage Vm of t is equal to 200 pi sine of 100 pi t volts. R is 20 ohms, E is 800 volts, and the inductor L is large enough to make the output current a smooth DC current. Switches are lossless. The real power fed back to the source in kilowatts is dash. Okay, this is not a multiple choice question, so let's work it out. We have been given a couple of things. Let's write that down. We have the supply voltage Vm of t, which is 200 pi sine of 100 pi t volts. This. We have alpha, which is the firing angle, given to us as 120 degrees. We have been given R, which is 20 ohms, and E, which is 800 volts. Now the value of L is said to be quite large. It's very large and the value is not given. And the switches are lossless. We have been asked the real power fed back. So the real power is the output power P naught, which in simple terms can be written as V naught into I naught. Now we need to find out what are the values of V naught and and I naught. So there is a general expression for V naught when we are considering circuits such as this. V naught is equal to 2 Vm by pi cos alpha, where alpha is the firing angle. Alpha is the firing angle already given to us. Vm is the peak value of the equation given to us, which is 200 pi. So these are some basic formulas. The real power would be V into I, and V naught is written as 2 Vm by pi cos phi. So if we substitute what Vm is, 200 pi here, let's see what we get. Okay, so we have V naught is equal to 2 Vm by pi cos alpha, which is 2 into Vm. According to the given equation, we take the peak value, which is 200 pi, divided by pi into cos of 120. So here we get the value as, that's minus 1 by 2, right? So it's 400 into minus 1 by 2. So we have V naught is equal to minus 200 volts. So since we have V naught equals minus 200, let's take the magnitude alone. So the magnitude mod V naught is 200 volts. So we have V naught, we still need to figure out the value of I naught. So here we use the power balance equation. Power balance equation. Okay, so let's look at the circuit. Now look at the output over here. Now this is a place where we will have to concentrate. So the power balance equation would be E times the output current I naught and the power dissipated by this resistor here, plus the power as a whole, the real power V naught I naught. Okay, so I'll write that down here. E into I naught is equal to I naught square R, that's the power across the resistor, plus V naught I naught, the real power. So we have the value of E as 800, we don't know what I naught is. We have the value of R as 20 plus V naught we just found 200. Now we solve for I naught. So that's 600 I naught is equal to 20 I naught square, and that cancels out. So we have I naught is equal to 600 by 20, and that's 30 amps. Now that we have the value of I naught, we have the value of V naught, all that's left is find out the real power feedback to source. So because we are finding out the real power, P naught is equal to a simple V naught I naught, and that's 200 into 30, 6000, which comes to 6 kilowatt. That's about it. So now let's see in what terms. It is in terms of kilowatt. So the answer is 6. Well, I hope this generalization has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.